So I put this tutorial together to show or demonstrate to somebody how to build a 40 kilohertz strobe light, essentially to synchronize the gamma in somebody's brain, and to kind of describe to you what that does. It's basically a potential treatment for Alzheimer's disease, and it was research done by MIT that was actually proven to reduce the beta amyloid protein in mice, and that's what causes the plaque buildup. And they think it's potentially what eventually causes um, Alzheimer's disease. But anyway, it hasn't been proven in humans yet. But there's a lot of people talking about it on the internet, and I just thought I'd put one together. This unit I built for less than $30 in parts. I'm gonna go ahead and turn it on so you can see how it works. It takes a little while to boot up, but once it does, it'll start creating a 40 kilohertz flashing pulse. Let me see if I can darken the room a little bit, which you can see a little bit in the video, but it's a little bit more pronounced when you see it in real life. But anyway, I'm putting this together to potentially help people, if there's anybody out there that could maybe build them and assist somebody, a loved one that might be losing their memory or might have effects of Alzheimer's. It's worth a shot, and for 30 bucks, it won't really hurt. Again, probably won't want to expose this to somebody that is susceptible to epilepsy with the flashing light just due to the strobing effect. But beyond that, it might potentially help people. And anyway, I would be really interested if you guys would comment on it. Again, this is kind of fairly rudimentary design, and if you guys have ideas on how to improve it, several other things, be to use different enclosures and such, that'd be great. Again, I put this together mainly for value, and just give people the easiest route to get a product like this in their home. Also, if you guys could comment on if you have built one and potentially helped treat somebody with it, that see if there's an improvement. If you guys do an cognitive test beforehand and then possibly after, you're supposed to expose people to it for, I think, an hour a day, or essentially the mice were exposed to it for an hour a day. And after 3 days, their beta amyloid was reduced considerably. So anyway, that's pretty much it. I'll go ahead and start moving ahead with the tutorial. If you guys have any donations, I'd be glad to take donations. My Bitcoin address will be on here. But again, I'm not charging anything for this, and hopefully you guys find it as useful as I have. Thanks. So anyway, here's the parts list I'll be using for the assembly of the 40 kilohertz light. I'll go through them individually. Here's kind of a wide shot of everything we'll be using. The first part here you'll see is an actual AC to DC converter. Essentially, it does the same thing as a standard power transformer. It has input, I think I can flip this over. It has some inputs on it for the AC line inputs in, that's for 110 volts. So that's what those two leads are. And then the output is on this side, and that's for 12 volts. And that's what we'll be using to power the rest of the circuit, including the LEDs and the DigiSpark. The next thing is essentially the brains. This is the DigiSpark unit, and what this does is regulate the actual pulse of the light. And I'll be going into a little bit more detail later, but essentially that's the DigiSpark unit, and I'll go into the wiring in a few seconds. The next thing that we're going to have is the N-channel MOSFET transistor. What that does is it actually takes the control variable from the DigiSpark and then converts that signal into a usable signal that actually will pulsate the LED lights. Here you have the actual LED strip, which you can buy in bulk, and we'll just cut to fit. There's small cut areas on the LED. This LED I'm actually using is a full spectrum LED, similar to daylight, for an added benefit, including the pulsation. Also offer people in the northern latitudes additional help when they're in periods of darkness, where again daylight or artificial daylight can help with depression and such. The other thing that you will need is a spool of wire. The gauge on this, I'm not too sure. I did get it at Home Depot, but I'll verify that and put that in the parts list. The last thing you'll need is the actual enclosure. I know this is a under-the-counter fluorescent light, but technically I'm not going to be using the fluorescent function. I'm going to be pulling the fluorescent light fixture out and replacing it with the LED strips. This I again purchased it because of its low cost. I think it goes for about $9 at any Walmart, so you can pick that up. Thanks. And then next we'll go over the actual board layout. So here's the initial breadboard prototype I did of the 40 kilohertz light, and I'll go through you each lead and kind of the logic behind it. The first leads you'll see down here at the bottom. Essentially, and again, to give you a small primer on a breadboard, which some people might understand the layout, especially if you're not in electronics. So I'll go and do that really quick. This two strips designate, well, at least the way I've set up, is positive and negative. So anything connected to these two rows, all of them are interconnected. So these all rows are entire one strip. So if you connect something down here, it will also terminate here. So this row is essentially, if you can visualize, is connected by one large wire. The actual rows on the top that are numbered are the same difference, except they're connected vertically as opposed to horizontally, at least what I'm showing you. These are vertical connections, so each of these rows are interconnected. And then the separation here separates these two sides. So these sides are completely independent and mirror images of each other, but they aren't interconnected. So anyway, going back to what we talked about, the way that I have this set up is I don't currently have the voltage regulator connected. This will just show you the logic between the DigiSpark board, and connectivity between the DigiSpark board and the MOSFET, and also the actual lights themselves, which that's a strip. So anyway, the way this works is the VIN connection on the DigiSpark is voltage that's inputted to the DigiSpark for power. Now the difference between the 5 volt and the VIN is very important. What the VIN does is allow you to input a variable voltage that's higher than 5 volt. In this case, we're putting 12 volts in. I don't know what the maximum is, but there is a small voltage regulator on here. I don't think it can take too much voltage. I want to say that on the upper limit it might be around 15 to 20, but again, we're running 12 volts in, and that's what this is, basically our positive terminal. So that's 12 volt positive input. The ground is of course the minus, so that's just universal, so that's your ground. And then the 5 volt you won't want to use in this capacity. I mistakenly did on one of my DigiSparks and actually started to smoke, so make sure you don't use the 5 volt when you're hooking it up this way. We'll be using the port 0 connection. That's really the only logic port that we need. The rest of them we won't be connected. And then the other thing we'll have is, again, the MOSFET connection here, which I'll go over into detail what some of the rails or the 3 independent connections are on the MOSFET. So anyway, the voltage is hooked up to the DigiSpark. The P0 is then connected to this row of, essentially this row is all interconnected like I mentioned prior. So when this is connected here, it actually connects all these. So this one is connected here, which is connected to this jumper, and then this jumper goes all the way over back to here, which essentially connects this terminal on the MOSFET. So that be the left control terminal. So basically this sends control information in 40 kilohertz pulses to this, all the way to this connection here. And then what happens is from here, you're actually regulating the voltage to the LEDs, but instead of turning on or off the positive terminal, you're actually turning on and off the negative terminal. This reduces some of the strain on the MOSFET. As far as the research I did, it's the best way to hook it up. So anyway, your control is here. So that's this leg of the MOSFET. And then up here, you'll notice that we'll have the purple connector, or the purple jumper, that goes all the way to the negative terminal. here. So this is the negative terminal that's connected to the LED. So if you go down here, that would be this middle pin. So middle pin goes to the negative terminal on the LED, and then the left pin goes to the control on the DigiSpark. And the next thing that we want to hook up is the positive terminal from the power. So basically the positive terminal is jumpered from here to here, thusly connecting this positive jumper. So the positive on the LED is always essentially connected. So that's what this positive is. This connects back through here. So this is a straight connection. The next thing that we're connect is the actual negative input, which is going to be the, let me see, actually, yeah, that's going to be this input, which is this negative input that goes to the right connector on the MOSFET transistor. So essentially what this does is this inputs essentially the negative, or not inputs, but this terminates the negative input to this right pin. So what this does is, as the signal is being sent back through here to the left pin, the middle pin is actually terminating, jumpered essentially in the MOSFET. It's going from here to here in a rapid state. So it's turning on and off in a rapid state. So essentially what happens is that turns this connector, which is the negative connector on the LED, on and off in a rapid capacity. So anyway, that's pretty much it. That's the whole circuit. The only thing that's left out of this is, of course, the voltage regulator, which, if I had it hooked up, again, would be somewhat in this configuration. Actually, make sure that's your AC input. So essentially the DC inputs from here, which actually I'll flip it over. This might make a little more sense. The DC inputs from here, which that's plus, so yeah, plus would go to the red, minus would go to here, and then your AC 110 would go to here. So this converts it to 12. This is your essentially 12 volt rail. And then the only thing that's connected is, again, your DigiSpark, and then a direct 12 volt connection to the LED, which always stays terminated, and this regulates the negative. So anyway, I'll be going ahead and putting together the circuit step by step, and then showing you video clips of each step, hopefully, and laying out everything as before I'm gonna actually install it in the light itself. Anyway, thanks. So I started off by placing the MOSFET on the DigiSpark, and I essentially bent the pins in the position that were going to need to be placed in the pins in the breadboard layout that I have here on the left. So essentially all I did to simplify things was flip the MOSFET over, connect up pin 0 to what is now the right pin, essentially just reversed of what we had it. But anyway, this pin is correctly connected to the control pin out, which is the pin 0 out, or P0 on the DigiSpark. The left side, in this case, is now connected to the ground where it needs to be. And then the middle portion of the MOSFET is going to be connected to the ground on the LED light. The benefit of this is, again, to minimize the footprint, or make the actual build a little bit smaller, so we can actually get it into the light fixture. There's a small area, which I'll show you later, that we need to fit it into. The other benefit of this design is it does expose this metal piece, as you can see on the MOSFET, and that metal piece here, just gonna grab this pointer, that metal piece, which is, hold on, sorry about that. The metal piece here, sorry about that, is actually also somewhat of a heat sink. So again, we're not really moving hardly any voltage through the MOSFET, so it barely even gets warm when I run it over 24 hours, if that. But anyway, this does act as a heat sink to when it does actually, if there's any heavy load that it is alternating, it will release a very small amount of heat. So that's why I mounted it upwards. So anyway, that's the first step, and then we'll move on to the next step. Using my soldering iron, I went ahead and soldered those two connectors that I was showing you. Basically that one, zoom out a little bit, that connector, and that one I just put a small bead of solder on it. I'm not going to go into too much detail on soldering. There's plenty of YouTube tutorials on how to solder, so I was just showing you that I soldered those two connections, as you can see. The other thing I forgot to show you that I'll be using is just standard Scotch double-face tape to connect these two components together. My plan will be to take the DigiSpark and put a small piece of double-face tape so there's obviously no, it doesn't short out the unit, and I'll be sticking it to the back of the voltage regulator to again minimize size, approximately in placement right about there. So anyway, I'm going to go ahead and do that. Here's the piece of double-face tape I cut to fit that's going to go on top of the voltage regulator as so. So let me see if I can do this one-handed. So I'm going to pull that off, that there, and then this is going to be affixed to the back. So placement's going to be approximately about like that. And that should be pretty decent. Let me see if I can push it down a little bit. As you can see, it does leave a nice gap between those leads just so they don't short out. But yeah, that's going to be the connection. And then what we'll do in the next step is go ahead and connect the voltage leads, the variable input, which is VIN, to the plus, and then the 5-volt negative to this negative terminal. So I'm going to connect both those next. I was going to attempt to use the wire I purchased for this step, but for these two connections, since I was able to get them fairly close, wire that was a little bit more rigid would be more optimal to connect those. So I'm going to go ahead and just use my breadboard jumpers, a couple of them, and I'm going to trim them down and then solder them into place here. I will be using some of this wire later, but again, it's going to be to connect up some of the other components, including the LED lights themselves. But to jumper those two connections, I'm going to go ahead and see if we can go ahead and use those and set that up. So that did work fairly well. As you can see, the solder connections are set up. I can't zoom in too far because I'm using a phone to, but anyway, so the zoom rate's a little bit shallow. But anyway, as I was saying, this connection is now connected to the negative terminal, and those are soldered in place. And the positive is connected to the positive terminal, which again, you can tell right there. So that's connecting up to the variable input, the VIN input on the DigiSpark. I know it's a little bit hard to see just because we're starting to put in components. Obviously, they're starting to cover up, but you can kind of see it a little bit clear right there. The shielding did melt a little bit on this cable, but I'm still pretty happy with the setup now that that's set up properly. What we'll probably do is once this is all connected, I will cover like the positive lead with a little bit of liquid electrical tape, as well as some of these other leads once everything's finished. I went ahead and cut 2 lengths of wire from my spool, approximately about 2.5, or actually, sorry, 3.5 to about 4 inches long. These 2 leads are going to be the connections that we're going to use for the LED itself. So this connection is going to be going to the negative portion of the LED strip, and then this connection is the positive connection, which connects directly to the output from the voltage regulator. So anyway, that's this connection here. I can zoom in a little bit better. So that's the positive output is going to go here, and that'll be connected to the positive terminal on the LED, and then of course the negative is going to come off the MOSFET, which is regulated by the DigiSpark Arduino. So anyway, that's going to be that connection, and I'll go ahead and show you that once we start assembling the light. The next portion, I'll show you how to disassemble the light and pull out the internal and components that you don't need in setting this up. So anyway, that's it. I went ahead and unboxed the fluorescent light. I'll go over its features and then I'll go ahead and show you what we're going to do to take the fluorescent tube and the electronics out and replace it with ours in just a second. So this is the light that I purchased at Walmart, and again, all the information as far as SKUs and such will be on the Google Docs link that I have posted later on down below in the comment section. So basically this comes with a standard AC cable. It's non-grounded and it'll be plugging in there, very similar to a laptop cable. It does have a switch which will remain enabled when we do set this up. So the switch will be active and you'll be able to turn the light on and off with the switch. And then at this point what we'll do is also pull the light fixture itself out. And the way we're going to do that is we're going to pull this lens out first, the plexiglass lens. I can't really do that one-handed. Fortunately, I don't have another way to hold the camera, so I'm going to have to do that off camera and then start the video back up. But anyway, I'll just show you really quick that there's these little clips that are handily put on the bottom, and you think you can actually just pop them off, but they do have a little bit of glue in each clip, so you do have to use a little bit of force to pop them off, and then we're going to have to re-glue them with super glue in certain positions. So I'm going to go ahead once we get this started and pop these just plastic pieces off. I'll kind of show you as I'm doing it gradually. The one that I'm going to leave intact is this one, because once all these are taken off, we'll be able to remove the bottom, and then this will pry up enough to where we can put our electronics in and then get them wired. So once the separation, we'll be able to separate this piece down at the very bottom. So anyway, I'm going to shut the camera off and then go ahead and start on that and then give you an update here in just a second. The plexiglass piece comes off very easily because obviously it's designed so you can replace the fluorescent light fixture. And all I did was slide a screwdriver underneath the plastic portion of the outside, and then of course underneath the plexiglass, and then just pop that off. So I'm about to pull that out. So let's see if I can do it one-handed. Okay. So basically that's been removed. The next portion we're going to remove the bulb, and then I'm going to show you how to pull the bottom off here. So to remove the plastic cover, I'm just going to go down the line and actually put the screwdriver in place and then just pry that. These ones I've already kind of popped off. You got to put a little bit of force behind them to get those plastic pieces off. I'm trying to hold the camera and do it at the same time, so to show you kind of an example. But once you get down to one, you'll kind of hear it pop. And again, you just place the screwdriver between within this slot, and once you get to one that needs to be removed, you just kind of twist it, give it a twist. So it'll pop off. Again, it's attached with very light adhesive, so it shouldn't really break the bottom. At least most of them come off fairly easily. If one were to break slightly, it doesn't matter because we're going to be reattaching them with some super glue. But anyway, the only portion that's going to be a little bit more difficult is this portion, which you'll probably need a little bit more of a precision screwdriver to get in there than the one I'm using. So be good to have that. And then the only two that pop off on the end are these two. So once you get that precision screwdriver in, that should pop off. But once I get to the bottom, I'll kind of show you another video of how it looks when it's completed and all those all the bottom pieces are popped off. So this is what it looks like with the bottom removed. I went ahead and removed the bottom completely, even though I did say I was going to leave this piece attached, just because for the example of showing you guys what it looks like on the inside, it's a lot easier. And again, all these you're just going to super glue at certain points anyway once we put it back. So realistically, taking the bottom off isn't really a big deal. So basically, once we get this done, the next step is going to be removing this component, and then we're going to go ahead and cut the wires that we don't need, especially these leads that go down to here, because these are again for the fluorescent tube. Oh, also I did want to touch on. I did want to show you just one thing. This is a standard fluorescent tube. All you have to do is twist and then pull it out. When you do remove the tube, it's like any other fluorescent tube. So if you look at the connector, obviously it's horizontal and then you just want to twist it vertical, and then these pins will just pop out. The tube's still good, so I mean theoretically, if you got somebody that needs a fluorescent light, give it away, or you know, potentially I guess recycle it if you have to. But anyway, I'll go and get the bottom set up here, and I'll start pulling these components out, and then I'll show you some video as I go. So to get the connector out, I just grabbed it with some needle nose pliers and wiggled it a little bit. It is attached with a little bit of adhesive on the bottom, but it should pop out fairly easily. So that's the first step, is to go ahead and pop that out, so then you can remove the AC to DC converter. That's going to be the next step. So whoops, I'll go ahead and do that in the next portion of the video, and then I'll show you how we're going to get that out. So once that plastic piece is removed, the actual board just slides out. It isn't affixed in any way into this area. So this board will go ahead and slide out. So what we're going to do is keep this switch intact. As you can see, the switch is back there. To do that, we're going to go ahead and cut this white wire here. Let me see if I can show you a little bit easier with these needle nose. So we're going to cut this white wire here with some diagonals. Of course, leave this one connected to the switch. We don't want to cut this black one. And then we're going to cut the other wire that connects to this board right about here, right there, because we're going to use this black wire to run the lead to our AC to DC adapter. These cables aren't used, so I'm just going to cut the length of this cable out. You can keep that for other projects. I'm also going to trim these cables down to here, down there, and then cut that. We won't be using this plastic piece, but if you look, there's a small hole in it, which I'll leave this intact. It's fairly easy to run the wires that we need to, because they're really light gauge through this hole down at the bottom. So we're going to run our wires here, and then we're going to go ahead and put our LED strip on this piece right here. So we're going to go ahead and fix the LED strip to that piece here in just a second, and it's going to look somewhat like, well, I'll show you, but it's going to look like that. So it's going to be fixed here, and then the wires are going to go through that hole for our lead, and we'll just, this has tape on the back of it, so it'll just stick. So anyway, we're going to do that next. So this is what it looks like with the original AC to DC converter board for the fluorescent light removed. I just pulled this cable out and just cut it on the ends because we aren't going to be using that. And then I went ahead and cut these two cables. And then just make sure when you do cut this, this is the lead that goes into the board, which connects right there. And then I cut the other lead, which connects right about there, which is that white, well, if I can pull it, that's that white lead that's coming in. That's what that was connected to. So anyway, the next step is going to be putting the board enclosure back in here, the board that we made back in here, and then also putting the LED light, affixing it to the actual fluorescent fixture right on that little ridge. So I went ahead and cut the LED strip. As you can see, make sure that you do cut it to fit. Obviously, just get as much length as you can. Make sure you cut it on those on the actual scissor marks. If you don't, it'll damage the LED strip. But anyway, I just showed you that I pulled the adhesive backing off and then just placing it, you know, somewhat as center as you can onto that, and then pushing down. So basically, that's all set up. And then the next step will be just putting in our controller board and then soldering those two leads right there. And if you, for the minus and plus leads, in case obviously when you cut it, you won't be able to see them here, but if you go down to this next portion, you can actually see where those leads connect, which is the 12 volt and the minus right there at that point. Anyway, I'll go ahead and set that up and then we'll test it out. So this part, I'm going to show you how to program the DigiSpark Arduino. Basically, I have here a Windows PC. It's just a standard Lenovo laptop. Here are the two install files I'm pretty sure that you're going to need to do it. I want to say there might have been a third file, but I'm pretty sure these are the only two files you need. The first file I downloaded was the Arduino 1.8 Windows compliant version, and then DigiStump drivers. These are the drivers I were able to locate just from doing a little digging on the internet. that I needed for the DigiSpark. I'll also include in the document that I post up there URLs to these two install files so you guys can download them. So basically after setting those up, and basically also actually wanted to go over one thing. The file, the DigiStump drivers files obviously needed to connect to the actual Arduino, DigiSpark Arduino. So that's what you need to connect to it. So the other one is obviously just the source software for the development platform for Arduino. So anyway, let me go ahead and close out of that. Once that's installed, it will create an icon on your desktop. I'm going to go ahead and open that up. This already has the code open, and I just called it Flash. And basically, it just pre-opened it because I had it opened earlier. But anyway, this is the source code that we're going to upload to Arduino. And I don't know the code. I'm not too fluent, but I was able to modify some strobe code that I did find on the internet to hopefully achieve, again, a 40 kilohertz cycle based on what I calculated. So what the code's doing is it's just establishing the constant, which is out pin equals 0. So that's basically telling which pin out to use on the Arduino, and that's the one that we soldered to, which is the pin 0, as you can see. Actually, it's covered up a little bit. So pin 0 is specified here. The output low is the next specification, and again, I'm not too fluent in the code, but I know at this point when you go down, it does a delayed write to high and then low. So essentially that's what creates the pulse. And the calculation Lisa I did, I think, was 13 and 12 nanoseconds. I think that's what that translated into. So basically those are the two modifications, the original code that I made. Again, if you guys have any improvement on this or you see an error in my code, let me know, but I think that's how I specified it, and that seems to work. So basically to connect to the DigiSpark, you're going to need one thing that I didn't specify in the beginning, just a standard USB micro cable. As you can see, it's got the very small connector on it, and then standard USB on this side. So the way this works, and again, I'm going to hopefully be able to pull this off while holding the camera, which might be a little difficult. I might need to shut it off here. But anyway, let's give it a shot, see if we can do this. Maybe. Oh, I think I got it. Ah, there we go. So basically the way this works is you have to initiate the write from tools, from the Arduino interface. You have to go over to here. Actually, I think it's under sketch. Sorry, not tools. It's under sketch and then upload. So what that does is it gives it a 20-second timeout. And you have to do that for this DigiSpark, because what happens is, actually I'm going to go and plug it in while I'm talking to you. But anyway, what happens is it initiates the USB only for like 5 seconds once you plug it in. So basically what just happened is once you plug it in and initiate the USB and allow you to upload code to it, after I think it's a 5 or 10 second interval, it disables the USB interface and it starts using the USB interface for other things, according to what I read online. So basically what you have to do is, again, initiate the code under sketch and make sure you get it ready. And then once you do that, you should see the 100% complete once it uploads the code, and that will tell you that it did upload to the Arduino properly. And then also you'll get a red light on there as well. At this portion, you don't need it to be powered because it gets power from the USB interface. So just remember the steps to do to, basically initiate the transfer and then plug it in. You just have to remember to do that. And there's a lot of documentation online to do so. But the next step will be installation of our package that we assembled into the light fixture itself. Now that the DigiSpark Arduino is programmed, we're going to go and get this installed in the actual light fixture. I went ahead and stripped the two cables that were leading from, one of them is the neutral cable that's coming off the AC plug, which is white, and then this is the actual powered 110 cable that's coming off the same AC plug, and that's going through the switch. And I went ahead and stripped them fairly short just because the actually area that we're going to be working with is very small. The two leads we need to solder onto are those two right there. So yeah, they're fairly small. They're going to be a little bit hard to work with, but it should work out. I went ahead and soldered those two connections. As you can see, it's a pretty tight fit, but if you do, it does help to strip the cables fairly short, and you should be able to get in there. But if you can see, the black cable goes to the left terminal, and then the white cable is going to go to the right terminal. That's from the bottom, and the left terminal is just to the left of that slit. So basically that's how it's set up. I'm about to run the two cables into the fixture itself, the two 12-volt leads. Now I went and marked this 12-volt lead with a black marker just so I can disseminate which one's the negative and which one's the positive once those are connected and put into the main fixture. So now we've got the Arduino and the power supply and the MOSFET all tucked away with those two solder joints on that I showed you before. I went ahead and finished the two solder joints that I needed on the, let's see if I can focus that a little better. The two solder joints that we needed on the LED strips, and again, those correspond to the positive and the negative that we terminated here, right there. So what we're going to do right now is we're going to try and turn this on and hopefully see if it works. So I'm going to go ahead and get the power hooked up here. Let's see here. Okay, right now the switch should be in the off position, I think. Let's test this out. And you can kind of tell that it does turn on because the red light will come on the DigiSpark Arduino. So let me see if we can fire that up. Okay, so the switch is on. That's good, we're getting the red light. It should be booting now. It takes about a minute or so for it to fire up completely. But yeah, here we go. So that's the actual LED light working. See if I can get a little bit better picture here. Seems like it's not quite focusing. I think it's due to the phone that I'm using to video this. Let me see if I can step back a little bit. You can't really tell the flicker rate in the video as good as you can in real life, just because the frame rate for the video is going to be approximately 30 frames a second. So it's going to miss a few of the frames as it's, or miss a few of the flashes that you're seeing. But when you do have it built, it is a noticeable pulse on that light. But anyway, that should be it. I'll go ahead and finish this up. Actually, that's a good shot right there. Kind of see it pulsating a little bit more. But anyway, that's it. I'll go ahead and get a video putting the bottom on so you can kind of see how that's reattached and super glued back on. So here's the unit with the bottom reattached. What I'm going to do is just go ahead and go down and pick, let's see if I can show you, pick key slats and just put a little dab of super glue on each of them. And I would alternate, I mean, maybe do that one, that one. And that should be good. Just enough to hold it together. Oh yeah, actually you should get these two ends. I'm gonna let that dry for a little bit. And then you should be able to put the lens on. I'm gonna just use this wire tie here to go ahead and flatten that glue out a little bit. Okay, but that should be it. I'm just getting these fine-tuned. That there. And then once they dry, like I said, we should be able to put the lens on. Anyway.